Hello and welcome to another exciting breakfast with Unity. We're going to continue on our little ballistic thing. So I'm going to just use the same folder that we had before. That's what we did last time. We did a two-parter, and so I'm going to keep that consistent. I renamed this part 1 at the end of the last episode, but I changed my mind. So what we're going to do here, first of all, what we've got so far is we have it set to the high angle now, and we can basically hit our target without too much difficulty by just aiming into that. We seem to have a little bit off. We may look into seeing why that is, but I'm going to first just focus on getting a couple features in. So, first of all, we want to have both of our angles available at any time. Right now, we just show one of the angles on this object called Ballistic Target 1, and this is the reason why I called it Ballistic Target 1. We're going to also create a Ballistic Target 2. And so, first of all, I want to just make sure, if we go to our ballistic calculation stuff, which is in first-person controller. Okay, it is still set to ballistic target 1. I just wanted to make sure, because when you duplicate sometimes... Well, actually, since they changed it so that this is in a different order now, it hasn't been as much of a problem, but when it was alphabetical, a lot of times it would switch which one was which, so this would just be ballistic target 2, because we basically renamed 1 to 2. Like, if I rename this to 3, it'll show up as 3 in there. I'm probably explaining this more than needs to be, but I've run into trouble with that a couple times. So let's make it so this thing can return 2 values. So right now we just return a float. We could return a float array. That would also work. We could just return 2 floats, and it could be empty if there's no values that are valid. But I'm going to actually go a little bit fancier and have it return a class. So we're going to do a public class. We're going to call this Ballistic Info. This is a way we can store more information as well, but right now we're just going to store 2 angles. So this is going to be, I'm going to call it float low angle and float high angle. And we have to make sure both of these are public, actually. Public float low angle and public float high angle. So now, another thing I want to change is we put a negative here to fix something. I actually don't want the negative there because this is returning the proper angle. It's just the way we're rotating wants a negative. So I'm going to put that back to positive and I'm going to negate it in this equation here. So finally, we want to actually not return just a float. We want to return the ballistic info. So we're going to create we're going to say it returns a ballistic info. And so now we can't just return angle 1. We have to actually calculate both angles and put it in here. So right now angle 1 represents the high angle, so I'm going to actually call it angle 2, just because I think the low angle is probably the more useful one typically, because it's the faster hitting. So we need to create a new ballistic info. So ballistic info return value equals new ballistic info. And then we can just set return value dot low angle equal, actually let's do dot high angle equals angle 2. And let's do, so right now, the difference between angle 1 and angle 2 is whether we put a positive or a negative here. And so if we want to actually calculate both, let's see. I'm going to do this a pretty inefficient way. We're going to call it top 2 here, and we're going to also have a top 1. And we will make this a little bit more efficient in a second here. So top 1, top 2. So what we're going to do is top 2 here, and top 1 here. And all we're going to do to change it is make sure the top 1 is plus as opposed to minus in that equation there. Or wait, is it, sorry, where is the equation? It might actually be a different place than that. What is it called? Ballistic equations. It's called like trajectory of a projectile, that's what it's called. Alright, let's look back at our equation. No, that's not where we put the minus. The minus stays there. We want, okay, so we want the plus here. There we go. So we save this. And you can already see that there's some stuff that we can simplify here. This is exactly the same as this, so we can pre-cache that and save us some multiplies, but there's actually a lot of multiplies we can fix. So can't convert float to ballistic target info, and that's because we need to actually... so I'm going to go ahead and, instead of return angle to, we want to do this. High angle. So this sets our high angle to angle 2 stuff in degrees, and then we want low angle, and then we return our return value, which is this ballistic info class. So now this shouldn't give us any problems. Oh yeah, because we're now expecting a float out of this. So what we want is, we want ballistic info equals calculate trajectory info angles, and then what I'm going to do here is target indicator dot local Euler angles. We're going to set to negative info dot high angle. So this should work exactly as we did before. So let's make sure that that works. So we should have a high angle version, and we don't. It's not moving at all. Why is it not moving? Oh, wait, we do. Oh, I just created another, that's our other ball that we made that isn't hooked up to anything yet. So that's our high angle. So if we change this to low angle now, low angle, we should get the low angle. Let's make sure that that's the case. All right, cool. That's the low angle for the trajectory. So if we shoot this at the dude, yep, comes pretty close to him. So what else do we got going on here? So let's make it so we can see both of them. So we're going to have target indicator. I'll just make 2 separate target indicators. Save. We'll change this to do target indicator 1, and then we'll do the exact same thing here. Target indicator 2, high angle. High angle. Save. So now, if we go into our script here, and we put in our ballistic target, for some reason both of them got clear, ballistic target 1 and ballistic target 2. Oh, it's because these are 2 different new names, so it was a new variable. Now we should have both the high and low angle, so we can do a double strike type thing where we shoot fire, whoops, where's the fire button? Fire, and then also fire, and they'll both, well, I timed that poorly. That high angle takes longer than I thought, so now we can do like that cool, where it's just like, let's see, let's wait it out. I want to hit him with like 2 explosions basically at the same time from one place. Yeah, it didn't time it well, but you can do that kind of thing, which is kind of fun. Just mortar strike things. So, so yeah, it does look like we still have a little bit of a problem with the actual targeting. I just want to make sure. So the ragdoll's target is at his feet, so we should be landing pretty close to his feet when we fire. Let's test the angles again. I'm gonna move back a ways, but not so far that I fall off the map. And I'm gonna go for the high angle here, and I'm gonna shoot. And how close do we get? It's just a little bit far. If I change, what was the one that had the, so we had this negative target Y, let's just try target vector Y real quick. Did I save that before I did, okay. Let's see if this fixes that slight misadjustment there. The other thing right now is you can't tell where the object is, so maybe we might want to add some horizontal information to it as well as to where our target is. So I'm going to fire that off. Let's see if that's any closer. Well, it's on the other side. I don't know if that's closer or further from where we want to be, honestly. Oh, that type didn't even explode. That's kind of unfortunate. Let's try the low angle one, see how that's looking. Looks like it's going a little far. I don't know. I probably have just some little assumption or something that's messing us up a little bit here. All right, so let's do. We've been 10 minutes in. I want to do some modification to make this a little bit faster. Right now we have a bunch of multiplies and 2 square roots involved in our calculation of the ballistic info. And we can really reduce this. So first I'm going to reduce it in a real-time scenario. So we reduce the number of times that we do it if we had all the values be dynamic. And then I'm going to make it so that the velocity is not dynamic and we can reduce even more. So let's just go ahead and do this. Our equation's not going to look quite the same once we're done with it. So what we're going to do now is we have velocity, right? So let's do float. Let's cache some of these. So we're going to do v squared equals v times v. So now we can use v squared here. And we only use v cubed once, so I'm going to just use v squared times v squared here. This will be appropriate because this is v times v times v times v. And we're going to put this part of the equation, because we use it twice, we're going to set this into a different thing here. We're going to call this float. What are we going to call it? We're going to call this the root values. So under the root. I'm going to call it under the root. Under the root. Equals. And what we're going to do is we're going to put the inside of this in here. And the reason being is this way we can check to see if this is negative. And if it's negative, we can find out that we don't have a target that we can hit. So, because this will return, if this is negative, that means you're outside of the range. Math square root will return a imaginary number. We can check for that, or we can just check to see if this is negative ahead of time, which is what I'm going to do. We've got a couple things we can fix here still. We can use v squared now instead of v times v. So that reduces our multiplies a little bit more. And what else did we use? We have g times x times x. So we could do x squared, although we're only using it one anyway, so it's not going to matter. So let's do that. So we can call this now under the root. We can put this in here. And now we can use v squared here, and we can again, and actually we want to do the math square root here. So float root equals under the root, and now we just say root here. So now we should have something that works identically to what we had before, but now we have reduced the multiplies considerably, and we've reduced the square roots by 1. So this is much more efficient with what we've done, and it's still completely dynamic, and it should work roughly the same as what we did before. When I say roughly, it should be exact, actually, but I like to say roughly sometimes when it's actually exact. So I'm going to shoot this guy. This is probably going to land a little bit in front of him because we don't have anything dialed in quite yet. There we go. So it's working. So that has saved us some time. Now, we could also make it even faster. In most cases in a game, you don't have variable acceleration rates for your projectiles. You just have a set rate, and that's what we have right now. And so if each of your weapons is only going to have a set projectile rate, we don't have to recalculate that stuff every time. So what we can do is we can pre-cache these velocity values. So what I'm going to do is I'm going to add a note here. Note, not live tweakable because of caching. And so we're going to put private, we're just going to do, I'm just going to set these things here. We're just going to make these 2 private variables. So private float v and private float v squared. And actually, we don't need any of these. What do we need? We need, yeah, we need these. So, so what are we doing? So now we've got these cached. We don't have to calculate those each time. Is there anything else that we could pre-calculate? We could do v v times itself a bunch of times. We can cache that one. So let's do that. V, well, it's not cubed. I guess it's hypercubed technically, if we wanted to call it that. Why not hypercubed? No one would ever call it this, but I'm calling it that. Because if you call it cubed to the third power, hypercubed is the fourth power. So we're just going to do v squared times v squared here. And actually, I don't think we can do it quite like this. I don't think we can set these values right here. So I'm going to actually set them in start real quick. So we're going to go into start. I'm going to move start up to the top because I like to be at the top. Not at the very top, but below our declarations. And we're just going to do these things here because I don't think I can actually directly set them based on... I might be able to, but I'm not going to chance it. We'll just have these not set at the beginning. And then we'll set them down there. So we don't need to redeclare, we just need to set them. So now, since we pre-cached that stuff, and since we have this new hypercubed thing, we can now go into the place where we have v squared times v squared. We can use hypercube. And what else? So yeah, I think that's about the extent that we can get to. So we have it now that we're at just a couple multiplies. I guess we could pre-cache. What else doesn't change? X changes, so we need that. G doesn't change, but X definitely does. And Y changes. So yeah, I think this is as efficient as we can make it at this point. So this one, we cache the information, so keep that in mind. If you have to change the velocity in the middle of the game, this later, this additional modification that we've done will not work. But all you have to do is basically just, instead of calculating these at start, you just calculate them each frame, and you'll have them. This one doesn't really save you on the each frame scenario, but it does save you in the pre-cache scenario. So so there we go. So now we've got a slightly more efficient method of calculating this stuff. Let's let's do 10 more minutes, and let's spend a little bit of time just making these targets not look so terrible. So we had done some stuff on a previous episode for the target info stuff. We had this reticle episode, and so if we hit play here, we can actually like look at things, and we get these little boxes here. So I want to actually use a little box for our targets. So I'm going to just duplicate our canvas here, just so that we have it. I'm going to bring this into reticles. Actually, I'm going to bring this into ballistic targeting, and we're not going to save anything that we changed here. We're going to ballistic targeting, we're not going to save. And I just wanted this so that we could see how this is set up. So we've got our canvas, actually we need a sight anyway, so that's perfect. So we have a sight now. So we can get rid of the sight ball. That's one thing that we can get rid of, which is in our main camera, it's just the sphere. So now we have a sight, and we have the ball still. And now we can make those balls look better. So I'm going to create, I'm going to call this... what are we going to call this? Ballistic target 1. I'm going to get rid of the text and little call out information here. Now let's leave it. Let's just change what it says. Let's make it say low trajectory. And then we will duplicate this, make ballistic target 2, and make the text say high trajectory. pi trajectory. And now, so these things, I'm going to actually rename them slightly. Ballistic target 1, HUD. Ballistic target 2, HUD. Because these have to be under the canvas, this makes it a little bit detached, which is a little bit strange, but I think this is going to work. So what we're going to do is we're going to get rid of the mesh renderer on the spheres. We're going to just, actually, I'm going to leave them there for right now so that we know what things are working. And we're going to create a script, and it's going to be called object position to HUD position. Actually, so I want to put this on the HUD elements themselves. Yeah, let's put it on the HUD elements. So, what do I want to call this? Position HUD based on object. That's what I'm going to say. Position HUD based on object. And what we will do is in update, all we're going to do, we're going to put this on our reticles that we just set up. We're just going to do transform.position equals camera.main dot world point to screen point, I think is the one we want. And then we feed it in our target. So our target is going to be transform, public transform, target. So world to screen point, target dot position. And that may be all we need. This might be the whole script. Save. So we're going to put this on our Ballistic target 1 HUD, we're going to put it on the Ballistic target 2 HUD, and then we're going to change target 1 to use Ballistic target 1, and target 2 to use Ballistic target 2. And if everything works well, we should see spheres with squares around them. And it did not work well. So, what does that mean? I was really expecting that to go a little bit different. So, they're not moving. That's weird. Oh, that's right. That's right. Because that's not actually what we want to follow. We want to follow the actual spheres here. So we put the sphere there. We put the sphere here. And then hit play. Does this work better? No, still not better. What have I done? Alright. I want to look at our older script real quick here. Target manager. Thought this was the most important part here. Transform dot position, world to screen point, target dot position. That's all we needed. Because the rest is just for resizing the actual transform. Huh. Well, why is that not working then? If I detach these from my camera, I just want to see if we can get to the point where we can find out where this thing thinks it is. Yeah, they're nowhere. There's nothing happening. Alright, what did I do wrong? It's okay, problems happen. So we'll get this figured out. Oh, we have a target manager as well. That's our problem. Let's remove this. Yeah, that's our problem. So if we hit play now, yay, it works. Okay. So we also have the extra one that we'll have to get rid of at some point. So now we have a high trajectory and low trajectory. We could make we can make these things so we can get rid of our spheres now. Finally, well, we can get rid of the renderers at least. Remove component, and we don't really need the mesh filter on it anymore either. And we're just going to call this indicator position, world position. And finally, let's make the target itself a little bit smaller. We're going to make the width, let's do 32 by 32. And again on this one, 32 by 32. And so now we have these nice little low trajectory, high trajectory targets that we can use to hit our target. So just fire it in there and fire it in here. Got him. Nice little double hit there. All right, cool. So I'm going to call this an episode. We might play more with this one more time in the future if people are still interested. And thank you for watching. You guys have a great one. If you have any questions, email me pushypixels@pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE. Hope you enjoyed the show. If you did and you have a little bit of money, please support us on Patreon. We really support it. We really appreciate it. Patreon.com/cookingwithunity, or you can find the link in the hamburger on the main Pushy Pixels YouTube page. Thank you very much, and you guys have a great weekend. I'll catch you on Monday.